Use the table to relate the independent variable x to the dependent variable y. Write an equation that shows the relationship. So we have to write an equation. Remember, equations have equal signs. And we want to figure out what is the relationship between the x and the y coordinate if you want to say that for this question. So we have to write down, we can use a table here. We can put x here. Our function is going to be here in the middle. And the function is just another way to say, how can I plug in a value for x or y and get the output? It's like an input-output table. You'll learn about all of these things one day. So it's basically an input-output table. And this is just the vocabulary that's associated with this. So when x is 0, what is y? So when x is 0, if we look over here at our table, y is also 0. So this might be a proportional relationship. And remember, a proportional relationship has three things. It passes through the origin 0, 0, which means that the x coordinate and the y coordinate are both 0. So this is probably a proportional relationship, which also it must be linear, which means it's a line going in the positive direction. And it also must increase at a consistent rate. So basically a constant slope. And slope is just rise over run. So if you're rising on the coordinate plane, we're talking about the y coordinate. So this is y. A change in y over a change in running is left and right. That's the way you run. So it'll be a change of y over a change in x. All right, so what is our function when x is 2? What is y? 8. So how do we start off with a 2 and end up with an 8? Maybe if we multiply by 4. So let's try that. 2 times 4 is equal to 8. And then we have, when we start off with 4, how do we end up with 16? Well, 4 times 4 is equal to 16. Okay, let's try another part of the table. If we start with 8, how do we end up with 32? So if we take the x value, 8, multiply it by 4, we'll end up with 32. So the function, the relationship between x and y, is that y is 4 times the value of x. So I'm going to put x times 4. So all of these right here represents my x value. So this is, I'm creating my function right now. We have 2 for the x value. We have a 4 for the x value. We have an 8 for the x value. So I can, instead of writing 2, 4, and 8, I'm going to put x. And then I have times 4. So I'm going to bring my 4 down. And then I'm going to put equals. This is going to equal the y value. 8, 8, 16. Y value. So this is the y value. So my function here is x times 4 is equal to y. So the value of y is 4 times the value of x. And then you can check to see if this is true. And remember, you can write equations in many ways. So this one of the equations, so the equation, and this is the most common equation where you put y is equivalent to 4 times x, and then you can put plus 0, but that's unnecessary. So you can write this equation, you can manipulate the equation. So if we were to solve for the variable, solve for x, we would divide both sides by 4 to get x on one side by itself. So another equation is x is equal to y divided by 4. And we could also isolate 4. So if I want 4 on one side by itself, I would divide x by both sides. And I'll get y divided by x is equal to 4. So that's another type of equation. 4 is equal to y divided by x. The main equation that you'll see is this point slope equation. Y equals mx plus b. This is the point slope equation where y is the y-intercept. M is called the slope. X is the x-coordinate. And wait, B is the y-intercept. This is actually the y-coordinate. All right, so what does the y-intercept mean? It's where your line passes through the y-axis. So this is the y-axis. So if the y-intercept is 0, 0, then it will go through the origin 0, 0. If the y-intercept is 0, -5, then the line will pass through the y-axis at -5. If the y-intercept is 0, 10, or if the y-intercept is 10, the line will pass through the y-axis at 0, 10. So that's all the y-intercept is. That's this B right here. Let's go to the next question. And if you can print this out, print it out. This is what we were going to write on for our notes, the rest of our notes. All right, so you can also use a graph to write an equation that represents the relationship between two variables. So this is another question where we have to kind of fill in the table and then possibly come up with an equation. So we're here. So we can use the ordered pairs to write down the relationship between x and y in the table. So when x is 0, because you remember x coordinate, y coordinate, the x coordinate tells you how far to move left or right. The y coordinate tells you how far to move up or down. So we will not move left or right along the x-axis. We will move up to 10. So the x coordinate is 0, the y coordinate is 10. Now we need to get this other ordered pair here. So if we start at the origin 0, 0, we have to move to the right 1 unit. So the x coordinate is going to be +1. And then we have to move up 9 units. So this ordered pair here is 0, 9. 1, 9. Then we want the next ordered pair 2, 8. Because we have to move to the right 2 units and then move up 8 units to get to that coordinate. The next ordered pair is 3, 7. And the next ordered pair is 4, 6. So with this, we can also see here that the y-intercept, where does the line pass through the y-axis? We can see that the y-intercept is 10 because the line passes, this is the line right here. Oops. This is the line right here. Where does the line pass through the y-axis? At +10. So we know that if we were looking for an equation, y equals mx plus b, and the point slope equation, or in the point slope formula, we have to know that the y-intercept is 10. So I know that b is going to be +10 in whatever type of equation that I write here, because I can see that right here. I can also see that I have a negative slope. How do I know this slope is negative? If a line is going to the right, the top of the line. So if I were to draw, if I were to go down with a pencil, I can see that the line is increasing. Positive direction is increasing. So this is the slope. This is the way that the line is moving. This is going to be a positive slope. So you have to go, don't look at the bottom of this. We don't look at the bottom. If we look here, the top is continuously increasing. It can go down as far as it likes. But if it's going up, if the top of the line going down, the top of the line is pointing to the right, this is called a positive slope. Now, if I drew a negative slope, it's going to go in the other direction. If I were to come down with the pencil, I notice that I'm going to hit this part first. So this means it's in a negative, on the negative side, which is the left side, more negative. This is called a negative slope. So this is a positive slope. And this one right here is a negative slope. So I know that since the top of this line, if I were to come down with the pencil, I'm going to reach this part of the line first. So this slope must be negative. All right, so now I need to figure out the relationship, which means that x is going to, m is the slope. That's going to be some type of negative number. So I want to come over here. Since I know that my y-intercept is 10, how can I put x and y together and somehow have 10? Well, if I look here, I'm going to make a function table where I put my x values here, my y values here. So when x is 0, y is 10. I'm just taking my ordered pairs. When x is 1, y is 9. When x is 2, y is 8. And when x is 3, y is 7. Now, how can I get 10 here? Okay, well, I can see that if I have, well, I'm just going to write, okay, so I see here that 0 plus 10 is equal to 10. I can see that, which is my x plus my y. I can see 1 plus 9 is equal to 10. I can see 2 plus 8 is equal to 10. I can see that 3 plus 7 is equal to 10. So if I wanted a function, for this, I would say, okay, my 0, 1, these are my x values. So I'm going to put the value of x. I see a plus sign. And then I see my y value. So the value of x plus the value of y is equal to 10. So this is a possible equation for this. And remember, equations can be manipulated. So we have x plus y is equal to 10. Now, I know I want to put this in my point slope formula, which means I need to move the x to the other side. So I will subtract x from both sides. And then I'll end up with y is equivalent to, notice that I have a negative x right here. Negative x plus 10. My y-intercept, where my line passes through the y-axis, is 10. So the value of y is equal to the opposite of x plus 10. So you can actually check to see if this equation is correct by substituting the ordered pairs back into the equation. So let's check for 2, 8. So this is our x coordinate, this is our y coordinate. Remember, x comes before y. So I'm going to put 8 in for x is equal to the value of 8 in for y, which is 8, and then I'm going to put my equal sign. Then I'm going to put my minus, and then I'm going to put 2 for x, because that's the x coordinate, and then I'm going to put plus 10. So let's see if this is correct. So I have 8 is equal to negative 2 plus 10. So I can rewrite that as 10 minus 2, and that is equivalent to 8. So this equation is correct. Now, another way to write the equation is also x plus y is equal to 10. Remember, you can write this 3 different ways. And we could also have x on one side by itself. So if I were to solve for the variable to get x on one side by itself, I would subtract y from both sides, and I'll have x is equal to negative y plus 10. And that's that. So we have 3 different equations. X is equal to negative y plus 10, x plus y is equal to 10, and y is equal to negative x plus 10. Now you remember you can put a negative 1, put a 1 in front of the x. So the slope is negative 1. So the constant rate of change is negative 1. So that means you will rise 1 or fall 1, and then you will run 1. Because a negative divided by a positive is negative 1. So if the slope was 5, you can put a 1, change it into a fraction, and this will be the slope. Rise, you will rise 1, and you will run 1. Rise 5 and run 1. And that's a positive slope. All right, let's go to the next question. So use the graph to write an equation that represents the relationship between x and y. Complete the table to start. All right, so we can see here that this is not a proportional relationship because it does not pass through the origin 0, 0. And the way that the graph looks, we don't know what the y-intercept is, so all we have to use is these ordered pairs. So we can see that the first ordered pair that we have is 5, 0. The second ordered pair is 10, 5. The next ordered pair is 15, 10. The next ordered pair is 20, 15. And the last ordered pair that we have graphed in the relationship in the coordinate plane is 25, 20. So we have to figure out what is the relationship between x and y. And we're going to do that right now. So we have to figure out the relationship. So I'm going to make a function table where I can find out the relationship between x and y. So I'm going to put x here, y here, and of course I'll put my function in the middle. And the function just means, how does the relationship between x and y function? What can I use as an equation to get the relationship? So when x is 5, y is 0. When x is 10, y is 5. When x is 15, y is 10. I see something already. Something with 5 lower than. When x is 20, when x is 20, y is 15. Well, it looks here that something with plus or minus 5, depending on which direction you're looking at. So if I look here, I can see that 5 minus 0 is equal to 5. 10 minus 5 is equal to 5. 15 minus 5 is equal to 10. And 20 minus 15, 20 minus 5. I want to keep the same relationship. 20 minus 5 is equal to 15. So if I look here, instead of writing 5, 10, 15, and 20, these are my x values. Oh, this is supposed to be 5, and this is supposed to be 0. Minus 5 of minus 5s, then my equal sign, and then I have my y values. So I can easily get a relationship by writing it in the table. So here's my relationship, there's my equation, and remember you can write that different ways. We can solve for the variable, we can solve for x, or we can solve for 5, negative 5, and we can make so many different equations, actually more than 3, because we can take the opposite of each one of these values. But so to complete the table, it said make an equation, graph and write an equation. So we already have this graph. We completed the table. The equation that we have is y is equal to x minus 5. So that y-intercept, where the line passes through the y-axis, is 0, negative 5. Notice that the y-coordinate is negative 5. So the y-intercept is always going to be 0, comma, a y value. I'm going to put a y right there. If it's below 0, obviously that y value is negative, and if it's above 0, that y value is going to be a positive number. Other ways to write this equation, we can move 5 to the other side, and we'll end up with x is equal to y plus 5. We could also check to see if these equations work by substituting values in. So let's try 10, 5. So this is our x value and this is our y value. So y is 5 is equal to 10 when y is 5, x is 10 minus 5. And notice that this is true. So this equation is probably true. You always want to check with more than one ordered pair. But I'm just going to check for one for the time's sake. And then I'm going to check this other one here that I'm manipulated when I solve for the variable. So when y is 5, x is 10. So this equation is also true. And the reason why it's true, because when I added 5 to both sides of the equal sign, I maintained the equivalent original equation. And that is just continuing what we learned when we learn how to solve for variables in the first quarter. All right, so that's that one. Hope you're more comfortable with this. Go ahead and try to answer this question on your own. And I will give you the answer on Google Classroom. So I want you to answer this question on your own. Use the graph to write an equation that represents the relationship between x and y. So you need to write an equation. So write that down. I'll actually put that in a Google form and you'll put your answer in. So this is Do you understand what I just went over? I also would like for you to answer this question. So if you need to go back to the other one, you can go back and pause it, answer the question on the side. And then I want you to come to this question and answer this question. Write the equation. All right. And that is that. Pause it if you need to. I'm going to go to the next part. So this is a really important objective to master for 6th grade. So suppose there is a $10 entry fee for a carnival, and each game costs an additional $2. So each game is going to cost $2. Make a table that reflects the relationship between the number of games and the total cost. So I'm going to come here. So total cost is the entry fee plus $2 for each game. So how much are you going to pay? So the total cost is going to be equivalent to, so is, that's like our equal sign, the $10 entry fee. So whether you pay games or not, you're going to pay $10 to get into the carnival. So how does that $10 affect the your cost, your total cost, which is Y? So this is going to be our Y, and this is going to be our X. So you're going to automatically pay $10. So that's going to be our Y intercept. If you play no games, 0 games, you're still going to pay the $10. So we have to add $10 to the final cost. And then plus $2 for each game. What does that mean? If you play 1 game, you're going to multiply that by $2. You're going to spend $2. If you play 2 games, you're going to spend $4. If you play 3 games, you're going to spend $6. So I can say the number of games times 2 is going to be how much money you spend only on the games. And that's only on the games. Then we have, okay, so we want to complete the table, come up with an equation. So the total cost, if we play 1 game, I kind of did this over there. So we will write 1 game times $2 for each game, plus the $10 entry fee is going to be equivalent to $12. What if we play 2 games? We're going to spend, multiply 2 games times 2, and then add the $10, that's going to be $14. And then we have 3 games. So if we take those 3 games, multiply by $2 for each game, and then add the $10 entry fee, we're going to pay $16. And then we have, let's say we play 10 games. We will take that 10 games, multiply by the rate of $2 for each game, and then add the $10 entry fee, and we'll end up with 30. And then we have 15. So we take the 15 games, multiply by 2, add the $10 entry fee, and we'll end up with 40. So we can say that an equation in my point slope formula, so 1 represents the game, so this is X. So the value of X times 2, because it's $2 per game, plus the $10 entry fee is equivalent to the total cost, Y. So Y is, and you usually see it in Y equals mx plus b, so I'm going to write it the way you would see it. Where Y represents the total cost, and you always want to know what each part of the equation represents. 2 represents the cost per, that's the division line, game, being multiplied by the total number of games. If you remember getting your units to cancel out, notice here we have games in the numerator and games in the denominator. It'll cancel out and give us money, which our final answer is in money, total cost. So you could think of it as that. Those are related. And then we have the $10 is represented by the entry fee, whether you play any games or not. So here's our equation for that, and remember that can be manipulated, but you usually see your equations in this point slope formula. Y equals m the slope times the x plus b the y-intercept. This is usually how you will see your equations, because y is usually the dependent variable, and then x is usually the independent. And then this is usually like, B is usually like your flat rate fee, whatever that is in whatever situation. Flat rate, that means you're going to pay that no matter what. And then M is the slope, the constant rate of change. Or in our case, we call it unit rate in 6th grade. 7th grade is constant rate of change or constant of proportionality. 8th grade, you will call it slope. So all of these words mean the exact same thing. All right, so this question right here, you can complete the table and come up with an equation. So go ahead and answer this one on your own. Remember to pause it if you need to. Go ahead and answer this one. And this one here. So those questions will be in a Google Form format on Google Classroom. And I'm hoping that you get those answers correct.